All right, first thing we're going to do is we're going to start simple again, but maybe a different problem. So we have 145 pounds, and we want to convert this to kilograms. What do we have to know before we can do this? How many pounds are in a kilogram, right? We have to know that. So on the exam, if I want you to go from standard American unit to metric unit or vice versa, I will give it to you. You don't have to memorize those. Which ones do you have to memorize? Metric to metric. Those prefixes that I gave you, those are the metric to metric conversions. Okay? And we're going to practice those today and try to get them down. My last class, I feel like we got on top of it. So I feel like we're going to do the same thing here. But please, stop me if it's not making sense, okay? Before I get to the very end and say, you know what, I'm lost. Start over, right? All right, so here I'm going to give you, I'm just going to give you a simple one that some of you probably already know, right? We know that 1 kilogram is the same as 2.2 pounds, right? Since they are equal, then we can put one on top of the other and have it a value of 1, right? We talked about this last time. So 1 kilogram over 2.2 pounds, and that's the same as 2.2 pounds over 1 kilogram. Any questions on that? Okay. They both have a value of 1, because anything divided by itself is 1, right? So if we multiply this by a value, let's say 145 pounds, it's still going to weigh 145 pounds. It's just going to be in a different unit. You with me? All right. So we're going to always start with our known value, in this case, 145 pounds. And we're going to multiply by, when we convert, we just multiply by a conversion factor that has a value of 1, so it doesn't change its value. So which one of these are we going to use, the first one or the second one? First one or the second one? First one, so that pounds goes on bottom so they can cross-cancel. Does everybody get cross-canceling? If you don't, I will show you something with just numbers. Anybody want to see that? Anybody? Nobody? Okay, going to move on. So, we do? Yeah? Okay, let's do it. So we have, let's say 4/3 multiply 6. Now, we can do, okay, 4 times 6 is 24, over 3 is 8, right? Do you get that mathematically? Okay. There's another way to do it. We can see that 3 goes into 6 2 times, right? Do you ever remember doing that, cross-canceling? That's all we're doing. Because 4 times 6 over 3 is equal to 4 times 3 times 2 over 3, right? And that goes away. That's what it is. 4 times 2 is 8. Do we get cross-canceling? Whether it's numbers or letters or units, it's all the same. If you have inches over inches, it goes to 1. If you have Andrew over Andrew, it goes to 1. If you have a million over a million, it goes to 1. You with me? Okay. Sorry, Andrew. Okay. All right, so 145 pounds, and we want to use this value of 1. So it's 2.2 pounds on the bottom and 1 kilogram on top. And that's why we chose to put pounds on the bottom, so that we can cancel the pounds, because we don't want pounds anymore. We're looking for kilograms. Does that make sense? And so we go 145 divide 2.2, and what do we get? Calculator time. 55.9? 65, thanks. 65.9 what? Kilograms. Because pounds are gone, and all we're left with is kilograms. So make sure you write everything out. Sometimes we think, oh, I'll just do 145 divided 2.2. Okay, then you're done. It's like, okay, what am I looking for? What are the units? But if you do this process, now this one's simple, okay? We know we're going from pounds to kilograms, so we know it's kilograms, right? But let's say we're going from pounds to grams. There's going to be more than just one conversion factor, right? So if we keep our work organized, we're going to be right, okay? And we'll know we're right, and I'll show you. Okay, so 65.9 kilograms is our final answer. Good? All right. Okay. Let's do one more that's a little bit more complex, yeah? So that was pretty straightforward. There's just one conversion factor. Let's do one that's a little bit more complex. Okay, we have 2.89 gallons of something, right? And we want to convert this to something else, some other unit that measures volume. Let's say milliliters. Do you guys remember what milli means?
So it's in the thousands?
A thousandth of a liter. 1 milliliter is a thousandth of a liter. You need to just know that, right?
King Henry died by drinking chocolate.
Yeah, great. If there's an acronym, no, that's great. No, some people love those. Yeah, do it. Perfect. Okay. All right, so let's see. We have to know conversion factors before we can do this, right? And like I said, we're going from American Standard Unit to metric unit. I will give you these, okay? So I will give you two of them right here. So I will give you 1 liter is the same as 1.0567 quarts. And I'll also give you 1 gallon equals 4 quarts. That's not quarts, sorry. Good? And that's how it'll look on the exam, for example. Okay? If I had you do this one. All right, so I'm going to start with what? Yeah, what I know, what I'm given. My value is 2.89 gallons. That's how much I have. And I'm going to multiply by a value of 1. What unit do I want to cancel? Gallons. I don't want gallons. What am I looking for? Milliliters. So I go until I have milliliters. So where do gallons go, on top or bottom of my fraction? Where?
Start on top.
It is on top, but where does it go in my conversion factor?
On the bottom.
On the bottom, so it can cancel, cross cancel. You with me? Okay, so gallons to what? Well, do I have any gallons right here?
So you just said that it's 1.0567 quarts. So are we going to go from quarts, convert from gallons to quarts to milliliters?
Oh, yeah. Well, so here's what we do, ladies and gents. Sometimes we say, okay, so what do I do first? What do I do first? Well, I know I have to go from gallons to something else, right? So gallons is a volume, so I got to go to another volume that I know the conversion factor of? Right here. How do I know it's that one? Because it has gallons right there. So you look at your known information and you see gallons. Okay, I know gallons to quarts. So I put quarts right here. Does that make sense to everybody? Okay? And, okay, so we know 1 gallon is the same as 4 quarts. Again, if we're doing this and we see this value is the same as this value, we know we're doing it correctly. Okay? And if the units are canceling, even more so. Good? All right. So let me erase this chicken scratch a little bit. Sorry, I get a little bit messy when I start circling stuff because I want you guys to see what I'm talking about. So if it gets too messy, let me know and I'll start again. Okay? All right. So grams goes away. And so now I need to get rid of what unit? Quarts, because I still want milliliters, right? So quarts go where? Everybody. On the bottom. Do we get this idea, guys? Okay. So quarts down here. And we use this one, so I'm not going to use that one again. Does this one have quarts in it? Okay, so I'm going to go to quarts to what? Liters, right here. And we know we have 1.0567 quarts to 1 liter. Quarts goes away. Cancel as you go to make sure you're doing it right. Sometimes we get all done and say, okay, but that's the wrong answer. Well, you didn't even check to see if your units are canceling. Yeah, you got to make sure you're organized so that you know you're doing it correctly. Or you know that you're not doing it correctly, right? All right, are we done? How do you know we're not done, Kai?
Because we haven't gotten the liters.
Oh, yeah, we're looking for milliliters, right? Yeah, so we have liters, so we got to do this at least one more time. But gosh, we ran out of known information, didn't we? We have no more known information. That is given to us, but we have to know the rest. Because what do we want to cancel? Liters, because we don't want liters and we want milliliters. We have to know how many milliliters to how many liters. I won't give you that. And milli is one of the most common prefixes that we use this semester. When I say that, I'm not saying only memorize milli. Get them all down. This is good for you to get all of them down. Okay? All right, so how many milliliters to how many liters? Who can tell me? 1,000 what? 1,000 milliliters to 1 liter. Raise your hand if you don't get that. Okay, so we're all 100% good there? Because I showed you how to convert from metric to metric last time, a different method, right? Do you like that method or no? I'm seeing no's. Okay, then don't do it. Don't use it, okay? So if you remember, in fact, are we all good with this? Do we know how to read this? Because this 1,000 is not even on our prefix, not on our prefix chart. So do we know how we got that? I'm seeing, it's hard for me to know if we're getting it. Okay, well, I'll just assume you are. Okay. So here we have liters goes away, and we're left with milliliters. Now we can stop. Now, there's another way to do this. In fact, before we do it another way, I want to find an answer. Does anybody know how to type this in your calculator? Yeah, 2.89, multiply 4, multiply 1, multiply 1,000, and we can get a number, right?
And then we move the decimal place.
Well, what is that number? Do it in your calculator. 2.89 times 4 times 1 times 1,000. What is that?
100, so it's 12215.452.
12245
No, 1225, excuse me, 12215.452.
Okay. Anybody else get that? For just 2.89 times 4 times 1 times 1,000.
Yeah, I got 11,560.
11,560. Okay, I need someone else to do it. What are we getting?
I got 10,939 points.
1,939. Okay. Woohoo! We're not going anywhere, are we? So that's okay. So 2.89 multiply by 4 multiply by 1, which doesn't do anything, right? Multiply by 1,000. We should get, I'm saying 12 times 1,000. We should be getting something like 12,000. Are we good? All right, so what does that tell us? We can even make mistakes on a calculator, right? So how do we avoid that? Anybody ever work construction? Ever make something? Yeah. What's a common rule you got to do there? Measure twice, cut once. Calculate twice, record once. Make sure we're good. Okay? All right, so we got, what's the answer again? I just erased it. 560? Okay.
Do we not divide by the 1.0?
We do. And this is not the way I do it, but I'm just saying, okay, we learned in maybe 4th grade how to multiply fractions, right? You times the top, you get an answer. You times the bottom, you get an answer, and then you divide them, right? If that's the way you like it, because you learned when you was 4th grade and it just stuck, keep doing it that way. It still works, right? And then we got 1 times 1.0567 divided by 1 is 1.0567. And then we divide those two, and what do we get? 10,939.72. Good? And if we round it to 2 decimal places, okay, good enough, right? Or actually we should do 3 sig figs maybe. Okay, but I'm not gonna test you on that. But then it would be there. Something like that, right? But again, I'm not gonna test you on how you round it. I won't. Master in chemistry might, okay? And if you want to know those rules, you read it. Is this my answer? What's wrong with it, Andrew?
It's in liters.
Ah, we need milliliters, right? There we go. Are we good? Okay. Now, the way I do it, I just multiply the guys on top and divide the guys on bottom. That's it. Just do one calculation rather than writing a number here, writing a number there, and then dividing. Why do I not do that? It brings chance for error. Because we already made one chance for that one error on that first one, right? I mean, we can still make error, don't get me wrong, but so anyway, that's how I do it. Now, anybody want to do it one step at a time and rather than all of it in one big? Anybody want to do it one step at a time? Yeah, let's do it. So we're going to do the exact same thing, but we do 2.89 gallons, and we're going to convert it to quarts. 4 quarts is the same as 1 gallon. Gallons goes away, so what's 2.89 times 4? 11 point something?
11.56.
11.56 quarts. Okay. So now, I'm not to milliliters yet, so I keep going. 11.56 quarts. And quarts goes down here so that it can cancel. And we know quarts to liters. 1 liter is 567 quarts, right? You following me, or am I going too fast? Too fast? Okay. So quarts goes away, and now I have liters. So what's my answer in liters? 11.56 divided by 1.0567?
10.94.
10.94? Liters, right? Okay. And I still got to go to milliliters. So I keep going. 10.94 liters. And you guys want to do it this way or do it the exponent way where we minus the exponents and how do you, no? I'm saying no, don't do it that way. Okay. Some people like it, and so it's okay to like it. It really is. So liters to milliliters, and we know there's 1,000 milliliters in 1 liter. Liters goes away, and so this is what? 1, 2, 3, 10,940 milliliters. Is that the same thing? It's rounded, but okay. Why is it rounded? Because we rounded each step, didn't we? And it's best, if you do it in steps like that, it's best not to round until you get to the end. Okay? So if you like doing it that way, do it that way. Just keep in mind, don't round until the very end. Questions? Now, I'm going to ask a question real quick. Does any of us do all of this in our head? Not in our head, but in our calculator. And just, okay, I know I got 2.89, without writing any of this down. Does anybody do it without writing any of this down? I'm asking you, please don't. Make sure you write it down. This is organizing it. If you're organized, your life is better, right? Forget about chemistry. If you're organized, your life is better. Same thing here. If you're organized, you're going to get it right. Well, you have a better chance anyway, right? There's always that chance of typing the wrong number in your calculator. So always double check that. Okay? Questions on this? Do we feel better than last time so far? Okay? All right, good, good. No questions though? All right. So let's, do you want to tackle that density problem again? And I'll keep it simple first. We'll start simple. I kind of just jumped the gun and made it right into where we're going. So I'm going to start simple again. So let's say we have 5 kilograms of gold, and gold is AU on the periodic table. It's to your advantage that you become familiar with these elements. And we're going to get into those elements a little bit more next week. So, let's see. Yeah, we have class on Tuesday because it's not Labor Day. Okay, good. So, 5 kilograms of gold, and we know gold has a density of 1.91 kilograms per liter. And we want to know what is the volume in liters. Good? So let's see. Is there a formula for volume or for density? Who knows it? Raise your hand if you know the formula for density. 1, maybe 2, maybe. A couple of us? Okay. Great. Well, if you know the formula for density, it might be to your disadvantage. And I'll try to explain why. Okay? Well, let's do it with the formula first. What's the formula? Density is equal to mass over volume, right? Now, do you guys like to plug numbers in then solve? Or solve then plug numbers in? In my experience, when I teach students how to solve then plug numbers in, it's a lot simpler. I'll show you. If you don't like it, I'm not telling you to change right now. Later on this semester, we'll be doing some calculations like that, and you say, oh yeah, it's way easier. I'm just saying, in general, that's what happens. Okay? So here we go. I'm going to do a little bit of algebra, because algebra works the same whether you're working with letters or numbers, right? Because letters are just numbers that we don't know what are, right? Same. So I want to solve for V, right? Because that's what I'm looking for. But V's on the denominator. I don't want to say per volume. I want it to say volume equals, right? So let's get that on top. How to do that? Multiply volume to both sides. And we got volume times density is equal to mass. We got to get volume by itself. It says multiply density, so we divide density. You all with me? Do we know how to do this? Did we talk about this at all? A little bit? No? Okay. So volume equals mass over density. I have my mass and I have my density. All I do is 5. Now, if you include units, you're going to notice something. If you don't, you might get it wrong and say, what the heck? I know how to do this. How come I got it wrong? Right? So 5 kilograms, always include units, over 1.91 kilograms per liter. I'm going to write that a little bit different. Per 1 liter. You guys remember flip and multiply? Multiply by the reciprocal? Yeah? No? So we can flip this. So it's going to be 5 kilograms. Multiply 1 liter over 1.91 kilograms, right? And that just tells us our unit is in liters. That's all. If you want to just divide those, you can, because that's what it is, right? So 5 divided by 1.91, what is it? 2.618. So this has 2 decimal places, or 2.62. Good enough? 2.62 liters, right? Okay, there's our answer. Now that's not what I'm trying to teach you here. I'm trying to show you a different way, and because sometimes we don't know the formula, right? Here we go. We're going to start with 5 kilograms. We could start with 1.91 kilograms per liter, but I like to keep things simple. Start simple. Kilograms, 1 unit is better than 2 units, yeah? But that's just me. You do you, okay? So I have 5 kilograms of gold, and I'm going to do this dimensional analysis. Do I want kilograms in my answer?
Oh no.
Yeah, in the end, I want liters. So it's important to know what you're looking for, right? Okay, so I use this. I'm not going to use it again. Can we use that? So I got to put kilograms down here. What can I convert to? Kilograms to liters, because that's kilograms per liter. Do you get that? Does anybody not get that? Need a more explanation? Okay. So it's 1.91 kilograms per how many liters? 1 liter. It's kind of like going down the street at 70 miles per hour. How far do you travel in 1 hour? 70 miles, right? Because it's 70 miles per hour, or in other words, per 1 hour. You with me? You understand that idea? Okay. So kilograms goes away, and we get 5 divided by 1.91. Isn't that what we just did over here? Same thing. 2.62 liters. We didn't know a formula, but we still figured it out. Isn't that cool? Okay. All right. But now it says sometimes using a formula is bad. Well, it's bad if you don't use units. For example, let's say we have 5 kilograms of gold, and gold has a density of 1.91 grams per liter, for example. Okay? And I know it can't be the same. I'm just picking numbers out here, guys. Okay? So we're going to do the same. Let's use density equals, well, we already calculated it. V equals m over d, right? So that means it's 5 kilograms, or sorry, just 5. Let's just do without units. 5 divided by 1.91. Well, that's the same thing, right? We get 2.62. You with me? But if we use units instead, 5 kilograms over 1.91 gram per liter. This gives us, we think this gives us liters. Is that right? No, because these do not cancel. We have to convert something before we use that formula, right? If we use dimensional analysis, we don't have to use a formula, we're just converting. It saves us a step. Good? All right. Questions so far? All right, let's so I'm getting a lot of you saying, so let's just try this real quick. Okay? Let's try another one. Another simple one. When I say simple, it's just not complex, that's all. I'm not saying it's easy. Okay? All right, so we have, let's say we have 32 kilograms, and we want to convert this to micrograms. I don't know you'd ever want to do that, but okay, let's just do it anyway. Okay? So this is metric to metric, and you have to know these. I won't give them to you. And I told you guys about the one note card you get, right? 3x5 card, yeah, yep. Not a 4x6, not an 8.5 by 11, just 3x5. One of those little, both sides. You could use both sides, but okay. So we're going to start. Now, you guys said you don't want to do the exponent way, right? Anybody like it? Okay. Then use it. If you like it, use it. Please do. Okay? It is an algorithm that you have to remember and make sure you do it the right way every time. It's always subtract, right? Okay? So, but if you like it, yeah, use it. Okay? So let's go through this. So we have 32 kilograms, and we don't want kilograms, we're looking for micrograms. Oh, I want to tell you something else. I forgot. In your guys' industry, in the medical industry, this is what we use in science. Micro is a Greek letter, okay? But in your industry, your field, that is MC, stands for micro. So this Greek letter mu is equal to MC. We're going to use both in this class, and I almost forgot to tell you that. So maybe you should write that. Who already knew that? Okay, great, great. So the rest of you, let's make sure we get that down. So MC is micro. Well, it kind of sounds like, right? Micro, okay? All right. I learned that when I started teaching this course. I'm not a medical guy. So, great. All right, so let's go kilograms. So we know we want kilograms on top or bottom? Top, you said? Oh, bottom, yeah, okay. So kilograms on bottom. And what are we going to convert to? Do we know how many micrograms there are in a kilogram? And I know some of you can probably figure this out. If you can, do it, right? I'm not saying don't.
It's like 10,000.
Okay, maybe. I don't know.
Go away from micro, or no, that's another.
Yeah, see, you try figuring it out so that you can save some time, and you might mess up. Rather than that, just use what you know. Does that make sense? And this is why I do this way. But I'm not saying you can't do it that way, okay? You probably can. You see how many tens away it is, and you can figure it out. But, okay. But I don't do it that way. Doesn't mean you can't. Okay.
Why do you do?
How do I do it? Like this. I'll show you. All right. So kilograms to what? What do we know? What does that prefix chart give us? To grams, right? Kilo means, what does kilo? Kilo means 1,000. So 1,000. So watch up here as I do this. 1,000 grams. Do you see how it says 1,000 grams on bottom? So a conversion factor has to be the same on top and on bottom, right? So we better put 1,000 grams. Are you with me? Make sure they're the same. If they're not, it's wrong. Did I lose anybody on that? Okay. So kilograms goes away. And do I want grams in my answer? No, so where does it go? On bottom. Grams to what? What can I convert to? Micrograms, right? Okay. So grams to micrograms, let's see. We've got to make sure they're the same values. What does micro mean? 1/millionth, right? I gave you that on your reference sheet. Know that it's a millionth. So how many millionths make 1 gram? 1 million 1 millionths. Do you get that, guys? 1 million 1 millionths is equal to 1, right? Okay. So that's one way to do it. Who needs a different way? Okay, I'm going to show you another way, just because some of us can't see that, and that's just fine. Okay, here's another way. Micro means 1 millionth, or 10 to the negative 6. Which one do you want to use? 10 to the negative 6? Okay. So this means 10 to the negative 6 grams, right? So we better have 1 times 10 to the negative 6 grams down here. Are we good? So again, I don't write that there. I'm just saying it's the same thing. So now we know we have the same values on top and bottom. Are you with me? And again, if you like the other method better, stick with it, okay? Really. Do it the way that works for you. All right, so here we have grams goes away, and now we have micrograms. So we have 32 times 1,000 divided by 10 to the negative 6. Do you know how to type that in your calculator? 32. Push the multiply button, 1,000. Then push the divide button and type in 10, and then the caret button, the negative button, and 6. Good? But I don't do it that way because I know what 10 to the negative 6 is. It's 1/1,000,000th, so I put a million right here. Watch this. So this is 1 divided by 10 to the negative 6, right? Mathematically, how do we change that exponent to be positive? Do we remember that? We bring it on top. If it's on top, it's negative, we bring it on bottom. I don't know if you remember that, but that's a math rule. And so we can say this is just 10 to the positive 6 on top. So instead of writing this, we can write this. Well, what is 10 to the positive 6? 1,000,000. So we can just write a million right here and a 1 right there. Good? Your call. I mean, try to make sense of this however you're going to do it. And I'm going to show you one more time, because I think some of you wasn't here last time. I'm going to show you one more time how to do it the other way with an algorithm. And if you like this algorithm way, use it. If that's way more smooth and more clean, and you just use it. But if you don't like it, don't use it. Okay, so we want to go from 32 kilograms. Oh, so first of all, let's find an answer here. What is it? 32 billion? Is that right?
32 times 10 to the 10.
Okay, 3.2 times 10 to the 10? Yeah, or 32 billion. Whatever, your calculator can put it in scientific notation or not, okay? Okay, so we have 32 kilograms and we're going to micrograms, right? I just keep writing it this way because this is what I teach in school. Sorry. Micrograms, okay? So 32 kilograms goes to micrograms. So what is the exponent? 10 to the power of what is kilo? 3. So I'm going to write 3 there, and then I'm going to subtract. Always subtract, never add. Okay? And then you have micro, which means what? 10 to the negative 6. So there it is. 3 minus a negative 6. That becomes plus, and we get 9. So that means it's 32 times 10 to the 9th power. And that's 32 billion. Oh. Maybe that's a little easier for some of you. Bryn?
Would you like us to, would you mark it wrong if we kept it in scientific notation, or do you want us to write it out, is it?
So here's how it will be on the test. On the test, it's multiple choice. So if the answer's in scientific notation, make sure it's in scientific notation. If the answer's in regular notation, put it in regular notation. Yep. Great question. Who likes that second way better? Good. Then use it. Then use it. Yeah, question. Sorry.
Sorry,
Remind me your name.
Carla.
Carly, yeah. Okay.
Are you able to do a question like the last one again?
Like the density one?
Like the one that you just did.
Oh, another metric to metric?
Yeah.
Yep, you bet. Yep. And you tell me how you want to do it. Do you want to do it that same method, the second way, or do you want to do it the first way?
The second.
Okay, perfect. Okay, let's do nanograms. Let's say we have 2 nanograms and we want to know how many centigrams that is. Okay? So what's our first step? What is the exponent to nano? -9. And this we have to know. It's still on our reference sheet. We have to know. Or it's, when I say reference sheet, the one we made last time, right? I won't give you that on the test. You have to know that, okay? Or you write it on your own little note card. But just know, as we go on, you're going to want more things on that note card. So if you memorize this big old sheet, you don't have to put that on your note card and you put something else on it. Just saying. Okay? So -9, and then what are we going to do? Add or subtract? Subtract. Always subtract, no matter what direction you're going. And if you want, I can prove this to you. But sometimes I show a proof and someone's like, don't ever do that again. Right? Whatever. Okay, so centi means what? 10 to the what? -2. So what's -9 minus a negative? Minus a negative turns positive, right? So we get equal to -7. You with me? So that means it's 2, what? Times 10 to the -7 power. And if you want to put it in regular notation, you can. 1, 2, 1, 2, 3, 4, 5, 6, 7, right? 0.1, 2, 3, 4, 5, 6, 2. And that's centigrams. Good? Any other questions before we move on to more complex problems? Well, let's see. We have a worksheet here. So section 3, there's 4 problems converting, but it doesn't tell you any conversions. So that means you're going to have to look them up on Google, right? Do you want to do any of these? You tell me. Or are we ready for more complex? Oh, you want to do them? Okay. So which one of these on this worksheet do you want to do? First one? We actually did something kind of like the first one. Let's do the second one. Okay, we have 26.2 miles, and we want to convert that to kilometers. Because this is something that we should not have to do, but we have to do it because we use miles. Yeah.
Sorry, do you have an extra?
Yeah, yes. Does anybody else need one? Here they are, right here if you need one. All right, so we start with 26.2 miles. Can we use that second method here? No, we cannot. We have to use dimensional analysis. Okay? What goes on bottom? Miles. Does anybody know how many kilometers is the same as how many miles?
1.60.
Okay, if you know it, you can use it. Let's say we don't know it. And I'm just saying this because, okay, let's say we're on test, we don't know it. They might give us on the test 2.54 centimeters equals 1 inch, for example. That might be the only thing they give us. Then we can't use, unless we know it. If we know it, we're good. We can use it, right? Okay, but I'm going to just pretend I don't know it because I don't. Andrew did, but I don't. Okay, yeah. But you still have it? Okay, good. So, let's say miles, do we know? Oh, we'd have to know another thing, right? 5,280 feet is equal to 1 mile. Okay, well, I'd have to give you that, right? Okay, so 1 mile is the same as 5,280 feet. I guess in reality, I'd have to give you another one, feet to inches, right? So what is it? 1 foot to 12 inches. Are you with me? Do you understand why 1 foot goes on bottom? So it can cancel, right? And now we have inches. Now we can use this one right here. So we used that one already. So 1 inch is the same as 2.54 centimeters. We keep going because we're not there yet. Centimeters to kilometers. If you want, you can find an answer here and use the second method, metric to metric. Right? Or we can keep going. There's 100 centimeters in 1 meter. Why? Because centi means 1/100th. So that means there's 100 of them in 1 meter. Yeah? And again, if you like metric to metric, doing it that second method, do it. Stop, get an answer here, and then convert. That method. Okay, we're not there yet, so we keep going. 1,000 meters on bottom is the same as 1 kilometer. And there we go. So that's quite a number of steps, yeah? Well, you just keep going until you're at kilometers. Any questions on how we did what we did? I had a student from my last class says, well, how do you know that you got to go from miles to inch or miles to feet? How do you know you go from feet to inches? How do you do that? How do you know? Do we have any questions on that? We good? Okay. And then, do we know how to multiply these and divide? How to calculate it? Multiply the top guys. So the way I do it, and again, you don't have to do it my method. I showed you a few. You do 26.2 multiply by 5,280 because it's on top. Multiply by 12 because it's on top. Multiply by 2.54 because it's on top. Divide by 100 because it's on bottom. And divide by 1,000 because it's on bottom. Equals. One calculation. And I don't know the answer. Actually, I might. Yeah, you should get 42.2 kilometers. Oh, not kilograms. Is that what we got? Okay. Do we need another one? Or are we ready for something more complex? Okay? Yeah, let's do it.
So the conversion from feet to centimeters will have.
Yeah, I will give you any conversion, standard American unit to standard American unit or standard American unit to metric unit. I will. I will not give you metric to metric. Okay? Anything else before we move on? All right, yeah, let's move on. So we have about 1 hour left. Yeah? And the next part, let's just go to the back side of this and do these. Story problems. These are the best ones. Why? Because they're real. When you guys are doing problems in the field, you're going to do real ones. You're not going to just do one like this. You won't. You won't do a conversion from inches to feet or inches to yards or nothing like that. Okay? You're going to do something real. Let me show you how to do these. And if I'm going to show you some steps. It's nice to know what to do first, right? And then what to do and so on. If you get these steps down, it's going to be much, much easier. And these are steps to a solving problem strategy. Okay? And some of you might know them, but I'm going to give them to you anyway. Okay, so problem solving strategy. Step 1. Before we can solve any problem, we have to know what the problem is asking. Got to know what the question is. What is the question? Or what are we looking for? What are we looking for with units? We have to know the units, and that's what makes it dimensional analysis. If we're not using units, we're walking on dangerous grounds to getting the wrong answer, okay? Step 2. So do you understand why that's our first step? If we don't know what we're looking for, we're shooting in the dark, guys. We cannot solve the problem. Step 2 is, what do we know? And when I say what do we know with units? What units do we know? Step 3, start our dimensional analysis with what we know. Because it doesn't make any sense to start with what we don't know, right? Okay, are we good? And I kind of told you these last time, didn't I? Okay, but I said I wanted to start again like it was fresh so that we get all the holes out of the way. So make sure you have these down, because I remember when I was in high school, go to the story problems in math class, and what do? You skip them. You just do the problems in the book, and you skip the story problems, and I'm okay to miss 1 or 2 because I'll be fine, right? I wish I didn't, but I did. Okay? And now I teach. I didn't like science when I was in high school, and now that's what I teach, and it's only story problems, right? Okay, so here we go. Let's do this first one on here. It says, a doctor orders a patient to take 100 milligrams of percentine, a blood thinner, daily. The available formulation is 25 milligrams of percentine per tablet. How many tablets should be given daily? Now, I'm sure some of you guys can do this in your head. I'm going to show you how to use this problem-solving strategy doing in this simple problem. When I say simple, I'm not saying easy. It's just not complex. Okay? Here we go. First step, what's the question asking?
How many tablets?
How many tablets? Any questions on that? Okay. And step 2, what information is given to us? What do we know? Well, the doctor gave us a prescription, right? And the prescription says 100 milligrams per day. And we can say per day, or we can just say 100 milligrams. Why? Because really what we're looking for is how many tablets should we be given daily? So tablets per day, right? Since it's the same time unit, we can just ignore the time. Does that make sense? Or we can just always keep track of the time. You with me? Should write that in a different color, though. So I'm going to just use the time just so that you can see that it still works, okay? So if it said the doctor orders us to take 100 milligrams per day, and the tablets are per 12 hours, then we have to have time in there, right? Okay, but since it's both the same, we can choose to neglect the time. All right. So do we know anything else? Yeah. So this says 25, uh-oh. We have 20, let's see. My pencil quit working. Give it a second, sorry. So we have 25 milligrams per 1 tablet. Do we get that? Okay. All right. Next step is we start our dimensional analysis with one of the known values. We have 2 known values, right? We can start with 100 milligrams per day, or we can start with 25 milligrams per tablet. What do you want to start with? What?
You wanna put milligrams on the bottom?
Should we put milligrams on the bottom? I don't know. How do we know?
Cause we're trying to find out how the.
Oh, we want tablets, so we better put tablets on the top? Does that make sense? We want it to say tablets equals question mark. We don't want it to say per tablets equals question mark, right? We don't want it to say per tablet. You with me? So great. So what does that mean we're going to use? What are we going to start with? Okay, let's start with 100 milligrams. Well, or we can start with 1 tablet over 25 milligrams. Do you get that? Because tablet's on top. Is this like a conversion factor? It is. We can start with either one. I like starting with this one first because it's simple. And if we choose not to worry about the day, it's even more simple, right? 100 milligrams. So 100 milligrams, we use that one, we don't have to use it again. Can I use one of these now? Do I want milligrams in our answer? We just want tablets, right? Question is, what are tablets? How many tablets, right? So we want milligrams down here so they can cancel. And here's milligrams per tablet, right? So 25 milligrams per 1 tablet. Questions? How I decided to do that? Anybody lost? Okay. Milligrams goes away, and our answer is tablets, right? And if we had day right here, it'd be tablets per day. Do you see that? Still works. Okay. And so that's going to equal 100 divided 25, which is 4 tablets per day. Good? Do you want to try the next one together or on your own? If you need one more, we can do one more. One more? Okay. But eventually, I want you to do these on your own. If you can't do these on your own, we're in trouble. Okay? All right, so the next one says, polysilin is available as a solution containing 250 milligrams per 5 milliliters. How many milliliters would you administer to give a dose of 400 milligrams of this drug? So first step is, what's the question? What is the question? What are we looking for?
How many mLs?
Yeah, milliliters. We're looking for volume in milliliters. Good? And what do we know? What are we given?
It's available as a solution of 250 milligrams by 5 milliliters.
Over 5 milliliters. Do you see that that's what it is? And we can all, this looks like a conversion factor, right? So this right here is the drug. And this is the solution, right? Are you with me? Or the amount of drug. So just know that as you're going through this. If you want to write it all down, you can. Okay? This is also equal to 5 milliliters over 250 milligrams. Do we get that? Anything that's a fraction, you can flip it, depending on which way you want to go. And right now, we don't know which one we're going to use, so we put them both up there. And we also know that we have what? Our dose is 400 milligrams of this drug. Okay, that's second step. Third step is start with what we know. Okay, we know two things. Which one of those do you want to start with? What? Milligram, this one right here? We can start with that one. Or we can start with this one. What makes you say this one?
Because they want to know how many milliliters.
Yeah. We want milliliters, and milliliters is on top. Last time we started with the easy one. Should we start with the hard one and see if it works? Let's do it. Let's do it. Just to show you, it doesn't matter which one you start with, right? We're just multiplying and dividing. Okay, so we have 5 milliliters per 250 milligrams. And we want to get rid of what? Milliliters or milligrams? Milligrams. Well, we use that one, so we don't have to use this one anymore. So now we got one more. We want milligrams on top so they can cross-cancel. And we have 400 milligrams, so it goes on bottom. Anything? Can I put a 1 on bottom? Yeah, why not? Okay. This is just 400. It's the same as 400 over 1, right? I should say 400 milligrams over 1. But we don't have to worry about the bottom because milligrams cancels out and we're left with milliliters. Personally, I like to start with the simple one. But you can still do it this way. You're going to get the same thing. So if we just turn these around, what's 2 times 3 versus 3 times 2? Same, right? Doesn't matter. So 5 times 400, that's 2,000. Divided by 250 is 8. Is that right? 8 milliliters of our solution. Questions? What if we didn't think to do this? Some of you guys might be thinking, how do I know? How do I do this? Right? Because these are icky, yucky story problems. So let's say I started with this instead. And ladies and gents, this is why I start with the simplest one. Keep it simple. But if I start here, 250 milligrams per 500 milliliters, or 5 milliliters, what do I want to cancel? Milligrams, right? Oh, I have 400 milligrams here. That goes away. We can put a 1 right there, no problem. Then we have 250, divide 5, divide 400. What do we get? 1 over 8, don't we? Or 0.125? Anybody do this? Do we get 0.125? Okay, let's say we got 0.125. It's the same thing, guys. And what's our unit? Milliliter. Our only unit is on the bottom. That means it's per milliliter. Do we want that? No, so what do we have to do? We just flip it. There's a 1 right there, isn't there? So flip it. What's 1 divided by 0.125? 8. Anybody would not want to have to worry about that? Then start with the simple one. That's all I'm saying. Good?
I just got lost on the first and the second one.
Yeah, don't do it that way. You getting lost? Don't do it that way. Start with the simple one. Or if you understand units, like Carla mentioned, she flipped it, and it's 5 milliliters over 250. She started with this one because we want milliliters on the top. That's what we're looking for. And that's a way to do it too.
More sense.
Yep. But I would have started with the 400. Just because it's simple. Good? And because that's what the doctor ordered. Okay. Why don't you guys try the next one on your own? And if anybody needs one-on-one help, let me know. I can come by, or maybe better yet, come and sit up here.
So here. Okay, so I did some of these at home, but then I did this in class. So I did it a little different than this method of like the 2 tablets times 50. I just want to know how we got here because the way I did it was a little weird. So I was thinking-
answer?
Yeah. Is that
Good.
fine?
Yeah,
Okay.
perfect.
I just don't want to
So-
mess up if I'm doing it different way in a different problem.
So it's, so this one right here?
Mm-hmm.
Okay, so the question is, okay, so all we're, so let's see, it says, okay. The kid weighs, or the person weighs 23 kilograms, right?
Mm-hmm.
And we're taking 2 50-milligram tablets. Yeah, I guess you don't have a pencil.
No, I don't, sorry.
No, that's okay. Just tell me how you did it.
Okay, so I thought of it as like, okay, we have 2 50-milligram tablets, so that gives you 100 milligrams.
Perfect,
And
perfect.
it's 23 kilograms, so I did like division, so like per 1 kilogram is 4.35.
Okay.
So then I used that as a conversion, right? That's the answer, right? It's
Okay.
4.35 milligrams per 1 kilogram. I think that was the answer, yeah? Yeah. So then the next one, when you have to use it to find for a 140-pound person, I did the conversion, so 140 pounds, and then I turned it into kilograms, so 2.2 pounds.
So for this one here?
Is 1 kilogram, so I get 63.64 kilograms, and then I multiply it by the milligrams per kilograms that I got, and then I got.
So one thing I would suggest though, is you have pounds here, pounds cancel, kilograms. So you get your answer, it's kilograms. And you times it by this, can I use
Yeah,
this?
go ahead.
Per 1.
Kilogram. Okay.
Write that so that we can see that the units cancel out. And actually write that the units cancel out.
Okay.
That helps you to know if you're doing it right. If things cancel out and you end with the unit that you're looking for, you know you did it right.
Okay.
Does that make sense?
Yeah, it's like a lot different on the answer key, so I just wanted to make sure that's still an okay
Yeah.
way to solve it.
There's a lot, yeah, if you get the same answer with the same units, yeah, you're good, you're golden.
Okay.
Just like I showed you here, I showed you like 3 ways to do the same problem.
Mm-hmm.
Right? You can do it.
Okay. So if it makes more sense that way, just do it.
Yeah.
Okay.
But the only suggestion is make sure you write your units
To
and
cancel
make
it
sure
out.
your units are canceling out.
Mm-hmm.
Because if they're not, then you might have made a mistake. It's easy to make a mistake.
Okay.
Good?
Yeah, thank you.
I'm just gonna step from where to go from familiar to, I know I need to somehow get familiar.
doing,
This,
okay, yeah.
that one. So I've gone from liters, gotten liters to milliliters, and
Okay.
now I don't know where to go from.
for it's 1,000.
Thank you.
And if you like to
Is 1,000 milliliters equal to
1 liter.
1? Yeah. So then I'm back to liters.
So,
Oh, that's
you-
correct.
Yeah, you
Yeah.
can cancel the liters, and now you have milliliters. Right?
Mhm.
So it's actually just show that they can. Okay. So now you have milliliters, and you have milliliters here. What are you looking for?
Milligrams, or how many
How
grams
many
of
grams,
glucose?
right?
Glucose.
Grams is measurement of what?
That math.
Right? And that's what, but can you see that milligrams is also a measure of mass? They're both grams, this was just
Mhm.
1,000 milligrams, right? Okay.
Mhm.
So basically, we're going from milliliter volume to grams, right, or to mass.
So that the mass and density?
Well, we don't want milliliters, so milliliters goes down here, right?
Mm-hmm.
So 100 milliliters goes down, milliliters go down here. And 85 milligrams goes on here. Does that make sense? Milligram. Because this right here,
It's just
Is
how
the
much
divide.
is in, oh, okay, so it's not,
that's a per means divide.
mhm.
It means the fraction.
Okay, so you're
So we
literally
can
gonna use
rewrite
that.
that as that.
Okay.
Does that make sense?
Mm-hmm.
So your milliliters goes away, so cancel those.
And you're
And we're now at milligrams. So we gotta
90
go.
grams,
So now we can go.
milligrams to gram.
That's it. And then,
1,000.
and if you like, that other method, then do it. So find an answer. We could have converted that other method right here too, right?
Mm-hmm. Yeah. Okay.
Make sense?
Yeah. Thank you.
Okay, are we ready to go over this one? All right. Okay, it says, in a typical person, the level of glucose is about 85 milligrams per 100 milliliters of blood. If the average body contains about 5.5 liters of blood, how many grams of glucose are present in the blood in a typical person? So what's our questions? How many grams of glucose, right? That's our question. What do we know? 85 milligrams of glucose per 100 milliliters of blood. And that looks like a conversion factor, right? So we could have it that way or the other way. And do you want to write it or no? Is that better? So equals 100 milliliters over 85 milligrams. Okay? All right. What else do we know? Typical person has how much blood? 5.5 liters of blood. Are we good? All right. Now, we got to decide where we're going to start. Where do you want to start?
With the 5.5.
5.5. Why?
'Cause it's
Simple. Simple, right? Keep it simple. Great. Is that the only place we can start? No. So let's start there. So we have 5.5 liters of blood. And let's see. We use that, we're done. We can't use that anymore. But this is milligrams of glucose per milliliters of blood. Oh, so we just need to get to what then? Milliliters, right? So we got to convert liters to milliliters so that we can then convert it to mass. Because you can't, without a conversion factor, you can't convert volume to mass. It just doesn't work. It's not the same stuff, right? So we know liters has to go down there, and we don't have anything here goes from liters to something of one of those units, right? It's not there. So we're going to go to milliliters, because milliliters is a unit of volume. Does that make sense, or am I saying too many words? Okay? So we want to go to milliliters first. Do we know how many milliliters to how many liters? Yeah. 1,000 milliliters to 1 liter. That goes away. And we got to go to grams, so we're not there yet. So now we're going to use one of these, right? Which one? First one or second one? First one, because milliliters is down here so that it can cancel out. So 100 milliliters on bottom, 85 milligrams on top. Questions? Okay. We're not at grams yet, we're at milligrams, so, okay, we used all of the given information. How do we go? So we know we want milligrams down here so it can cancel. What can we convert to? Milligrams to what? Can we go straight to grams? Yeah. We know that. And it's the same thing as this, isn't it? 1,000 milligrams to 1 gram. Milligrams goes away. We're left with grams. And that's what we're looking for. It tells us we can stop. So 5.5, multiply 1,000, multiply 85, divide 100, divided by 1,000, should give us 4.675 grams. How should we round our answer? We start with 1 decimal place or 2 digits. Should we say 4.7 grams? Good enough? But if it's on the test, how do you know where to how do you know where to convert? Because it's multiple choice. Good. And I'm not going to trick you and say, okay, is it 4.675 or is it 4.7? I'm not going to do that. Okay? We good? Questions on that problem? If we didn't get it, I would ask a question, or unless I covered it just barely. Okay? All right. We have 20 minutes. Do you want to do more on your own or some together? How are you feeling? Together? Okay. But do you guys get the process here? Okay, this next one generally throws people off. So again, look at the units. Know what you're looking for. So this first sentence just tells us information in general, not even about this problem, right? It tells us dosages are often given, amount of drug per body mass, right? It can be measured in milligrams per kilogram or micrograms per kilogram of body mass. Okay, then the question starts, what is the daily dosage in milligrams per kilogram? So what are we looking for? milligrams per kilogram. Starts with a question. Great. And what do we know? Of a body weight for a child weighing 23 kilograms, right? And this child takes 2 QTY. What is QTY? Quantity. That means he takes 2 50 milligram tablets. What can we write? There's two ways we can do this, ladies and gents. What do you want to write? What do you want to write here as the known information?
It takes 2 50 milligram tablets, it's 100 milligrams daily.
We could say 100 milligrams per day, right? That's what he takes. Done. As far as the given information. Does that make sense, or do you want to try another way? Okay? All right. Where do we start? They're both simple. Where do we start?
You wanna start with 100 milligrams?
Do you want to start with 100 milligrams or 23 kilograms?
What's the easier way?
Yeah, you tell me. Look at what we are looking for.
Milligrams to kilograms.
What's on top?
Milligrams.
So what should we start with?
100 milligrams.
Can we just do this? Yeah. Did we use dimensional analysis? Yeah. That's what dimensional analysis is. Making sense of the units. It doesn't look like a conversion problem, does it? But we have what we're looking for. We know we did it right, even though nothing cancels. We're golden. And so that's what, 4.35 milligrams per kilogram. And then the next problem, it says to use this. It says, how many tablets would we give this 140-pound woman to achieve the same dosage? Try it. Or, I mean, we can do it together, but then I'm taking your practice away.
So 140, what pound one? I didn't see it.
So, oh, do you not have one of these?
Sorry, thank you.
You're good. Got that one? Go on to the next one. If you're done, we're done. How we feeling?
Psyching myself out that it like really was, oh, you're good, that it like really was that, like, if it's, so a 50-pound child, they're 22.7 kgs, and if it's 75 for 8 hours, like divided out, it should be 3.3 mgs per kg Q8, right?
Yeah, so we gotta just compare that with that.
So it's just a matter of like, so then we say, how do they compare? Like, just like it's 1.3 mgs per kg
Well,
higher.
all I'd say, so this is normal renal function
Mm.
for people with normal renal function. And so this is what this child takes. So he has to take more than normal.
So just
That's it,
simply
yeah.
state like it's just
Mhm.
more. Okay.
Yep, that's it.
And then as far as the gentamicin one, I'm trying to find if she's 63.6 kgs, and I would just use a similar, so like I just used the same
Mhm.
formula dosage, so it should be roughly
Yeah,
3 times.
but it was more like 2 point
So it's
something, right? So should we round up?
I mean, with Gen,
With what?
with gentamicin,
Okay, so I don't know what that is.
dump it into roll joints.
Okay.
Literally dump it.
Okay,
So yeah, it might be like 2.712 or something like that.
yeah.
for Gen.
Oh, I don't know what that medicine is.
That's
I've
just
been
like
telling
that.
people don't overdose. Okay.
It's Gen, yeah, okay, just wanna make sure,
Yeah,
thanks.
thank you. All right, we good? Should we do this? All right, here we go. So I already wrote what we're looking for. Did you get this information? So this was from the last problem, right? So we're using that from the last problem. It says with the same drug dosage, and it's talking about the previous question. Are we good? Okay. So we're looking for tablets. Where do you want to start? 3 different places we can start. We got that information, this information, and the information from the last problem. Where do we want to start? 140 pounds? Keep it simple, right? Great. So we have 140 pounds, and we can convert pounds to what? Kilograms. So on the test, I would give that to you, right? But in your field, you probably should know this, right? This right? Okay. So 2.2 pounds to 1 kilogram. That goes away. So we use this one, we're not going to use that anymore. Okay, now which one should we use? We have kilograms, and the only one with kilograms is this one right here. Kilograms goes on bottom, so it can cancel out. 1 kilogram per 4.35 milligrams of our drug. And this kilograms is body mass, and this kilograms is body mass, right? So that's why it works. Then we have milligrams, so we're done with that one. So now we either use this one or this one here. Which one should we use? First or second one? Second one? Well, let's see. We want milligrams to cancel. So yeah, it goes on bottom, right? 100 milligrams to 1 tablet. Milligrams goes away, and we're looking for tablets, and we have tablets. Done. Sometimes we do it in class, and you feel like, okay, I got it, and then you do it on your own, like, do you feel that way? Okay, so what's the problem? You need more practice, right? Are we using the problem-solving strategy? These 3 steps? Are we showing all of our work? I would if I were you. Show all of it. And sometimes we say, okay, I got this, I could do this, I could just do it in my head, or I know how to do this, I'm good. Ladies and gents, this is not all we're doing in this class. Get this work down, be organized. When we get to the stuff in the rest of the semester, it's not going to be dosages. It's not. But this is the same math we do. We still follow these 3 steps, and we're good. So practice you showing all of your work. Any questions on that one? You want to do the last one? Okay. So talk to me. Now, I can do this for you. I can. But I don't need the practice. So talk to me. Tell me what to do. What's my first step? Read it, right? Okay. So we read it. What's the question? Somebody tell me the question.
How does it compare to
Oh, how do they compare? How does this 50-pound child compare to normal function, right? A normal function, they take a dosage of 2 to 2.5 milligrams per kilogram, right? That's normal function. Or that's the dosage for normal function. Okay? So we're comparing against that. So what are we looking for? We still don't know what we're looking for, do we?
dosage?
We're looking for a dosage measured in what? Oh, we're going to compare it with this, then we're going to get that. Does that make sense? So we're looking for milligrams per kilograms. What do we know?
50-pound child.
50-pound child takes 75 milligrams of this drug. Okay? Is this similar to a couple of them up? Yeah. We just need kilograms, right? 50 pounds to kilograms, so 2.2 pounds is 1 kilogram. And what's 50 divided 2.2? What is it? 22.7 kilograms. And we want milligrams per kilogram, so what do? 75 milligrams per 22.7 kilograms. We have the unit, we divide it, what do we get? 3.3 milligrams per kilogram. Is this our answer? No, we got to compare it. Compare it against 2 to 2.5. So this kid, is he regular? No, he has to take more. That's all we say. Make sense? Okay. Get this down, ladies and gentlemen. Get on to Khan Academy if you need more help. And I will try to come up with another worksheet and send it out to you. You don't have to do it. It's just extra practice. Andrew.
You have the answers to the worksheet?
Yeah, the answers to the worksheet are on Canvas. These worksheets that I have here, that I give you, the answers are on Canvas. Do you guys know where to go? Should I show you?